This is the new HD Bender, and it was designed specifically for those of you who are interested in RC fabrication. This is designed to bend 3/16" tubing, similar to what I've used to build this cage here next to me. In today's video, we're gonna go through why I felt this bender was needed, how it's made, how you can buy it, how you build it, and how you use it to get tubes that come out exactly like you planned on every time. And lastly, how you can get a hold of this angle finder that'll tell you exactly how far you've bent your tubes every time as well. But let's dive in. First off, why does this thing exist? Why did I feel like it was needed? Well, there are other tube benders available that you can pick up every day. Specifically, and most commonly, is a brake line bender. Now, brake line benders have been around for a long time, and there's been a ton of cars built with them. But they're not ideal, in my opinion, for a couple of reasons. One, oftentimes the radius is larger than I think looks ideal on a build for a 1/10 scale cage. Secondly, they have to be a little bit more flexible in their design because they have to work with fittings and flared ends on brake line that we don't necessarily deal with on our scale. And because of that, you can end up with slightly less repeatable bends on a brake line bender versus something like this. Now, there are other benders on the market that are more specifically designed for things like this as well. But a lot of them, or most of them, all rely on 3D printed parts for a lot of the strength, whether it be for the hoop that actually supports the tube as you pull it, or the dies themselves in their entirety, as well as like the pressure die underneath. All of those relying on 3D printed parts to support that load can be an issue. And while there are ways to get parts printed out of much more higher strength materials, even metal, that does then also add to the cost. This bender does also use 3D printed parts, but you're not relying on it solely to carry the load of bending the tubing. That's actually done all through other laser cut parts, just like you see the frame itself is made out of. The forming die, or the round part at the top, is made out of multiple layers of laser cut aluminum with a thin portion of 3D printed material that goes around the outside to hold the tube exactly where it's needed. But again, you're looking at a very small portion of 3D printing, and then the rest of it is all aluminum inside. The pressure die underneath, where the tube actually slides in through, that has a 3D printed part that goes around the top side, and it holds the tube as well, but is supported underneath by aluminum. The grip portion of the handle is of course 3D printed, and then this spacer in the lower section is 3D printed also. This lower section is designed to fit down into your vise and give you an easy way to hold this on your bench. Now, all of this aluminum, how do you get that? The easy answer is Send Cut Send. And I've got another set of the parts right here. Send Cut Send has recently made things much, much easier though. What I'm able to do is come up with the design, upload it to Send Cut Send with the quantity and thicknesses of each part that's required, and then just give you the option to go add to cart with one button and not have to know any of the rest of the details, making it very, very easy as far as that goes. They'll cut all the parts and ship it directly to you, taking me completely out of the equation. You'll find a link below to Send Cut Send with these parts. And then you'll see one other link as well, which is for the 3D printed parts. Those are from my website. When you go to my website, you'll find these 3D printed files. You'll download those, and then you will be responsible for 3D printing those on your own. That does require that you have a 3D printer, or hopefully you can find somebody nearby if you don't have one yourself. But I myself don't personally offer any 3D printing services for people. On the listing of the 3D printed parts, as well as the laser cut parts, you will find a hardware list as far as what you need to get this thing completed. Some M3 and some M4 screws and nuts are required. Once you've purchased the laser cut parts and you finally received those, and then you've 3D printed all of your components, now it's time to assemble. And we're gonna dive into exactly how you do that. Now, when you take the parts out from Send Cut Send, this is what you're gonna see. The two sides, the two vice clamp blocks, one of the inner die pieces, the other inner die piece. This is the pressure die lower portion. the two handle bits, and then these two flat straps. Now, you only need one of these. I included a second as an extra because this is one part that you do need to actually bend. And I've got a jig for that included with the 3D printed parts so that there's not a lot of guessing involved in this. But again, I gave you an extra just in case. Now, right when you take these out of the package, they are just raw off the laser. You can see in there, there's a little bit of the remnants from the actual cutting process. You can see where the laser was piercing. And then on the other side, you may even see some, actual more witnessing of the laser cutting process itself. This is the time though, that if you want to have a little bit cleaner looking bender, this is the time to do a little bit of prep. If you've got a foam sanding block, this is an easy way to just do some graining and cleanup on here. It can help you get rid of any burrs. You can take off any of the sharp edges and just get everything prepped. One other thing that is nice to do is just clean up the holes themselves. You don't need a deburring tool to do this. You can do this with just a regular file, but these make it handy. You just stick that in there, do a quick turn, and it just puts a nice, perfectly smooth edge on there. Before I assemble this, I'm going to go through and do a quick prep on all of these parts. So we've done the prep on all of our aluminum parts, and now I've grabbed my 3D printed parts as well. Now, the parts that are actually used in the assembly is the vice clamp spacer, the outer portion of the die, the pressure die piece itself, and the handle. Now, I still have my supports on all of these because I want to talk about some orientation of these when you're printing. First off, talking about the actual materials and strength. Now, this is being clamped in a vise. So it's got aluminum on either side, so you're not going to actually damage the outside of this, but you are looking at the compressive strength of it. Most materials will likely be fine in this situation. Just if you print with a high or, 100% infill, you're probably going to have the best scenario. This one here is printed in PA6 glass fiber, which is a pretty excellent material from Bambu, but it is a high temp, does require an enclosure, and it's a little bit more of a high-end or specialty material than maybe a lot of people are ready to print with. But if you do have an enclosed printer or something like one of the Bambus, then this is a great option and something that I've found so far after some testing to be one of the best options. The handle itself, I do still have the tree support on. I can pull this off. I printed this handle with this bottom surface touching the build plate to give myself the best finish as it went up. After doing a handful of different versions of this and testing it out, this is the one that I felt is the best situation. Now, it does attach to the handle part here, so if you're bending and you're kind of holding out here, you are going to have a fair bit of force going through this handle. So if you print this again with a high strength material, it's recommended. Again, high infill rates may work best in a lot of cases. It's what my second choice for materials on this would be the ABS options, which also seem to do really well. This one just is initially showing a little bit more strength, which I am enjoying. Pressure die here, you can see also still has the tree supports on, and I just wanted to show that I was printing it in this direction, putting the actual layers in the way that it would kind of hold the tube. Gives you the smoothest finish through that section and seems to work really well. The outer portion of the die just prints flat in this direction. There's one other part to print, and that is this here. Now this is just printed out of some PLA, and this really doesn't matter as far as what material you go with. This is going to be our bending jig for one of those straps that we showed earlier, but we'll get to that here in a little bit. Not pictured or shown for the print files are some 3D printed washers that I have in there. Now you can use those, or you can pick yourself up some M4 washers. These are specifically M4 brass washers that are 0.8 millimeters thick. It's designed to use 2 per side. So the printed washer you're going to find is 1.6 millimeters, which replicates 2 of these washers stacked. So starting with the assembly, we're going to grab one of the sides and a piece of M4 by 30 hardware. We're going to put that through. Then we're going to put 2 of those washers or 1 of the 3D printed washers. Next, we're going to grab one of the handle pieces, and it should assemble in this orientation with the bend kicking outward. You'll notice on yours that you don't have that little slot, but that's really the only difference. Next, you're going to grab one of these outside parts, and the portion with the angle further away from the actual hole, that's going to go towards the top. Next, you're going to grab this part with the jagged outside. That's going to go on with this portion that kicks out facing outward, like that. Next, you can grab your 3D printed piece, and this is going to match the shape of that laser cut part. It'll snap in place and fit flush like that. Next, you're going to grab this thicker portion with a similar but smooth outside shape, and that goes on next. Then we're going to have the other side of the die, another handle piece, 2 more washers or 1 3D printed washer, and then the other side. Then I'm going to use an M4 lock nut. We're just going to loosely place it on for now. Now we need to line up this bottom hole on the arm with all of the other parts that go through the center. Using M3 by 18 or 20, you can put it through all of those parts and then add a nylock to the other side. Before fully tightening that down, we do want to put a piece of hardware through that upper hole just to make sure everything is in proper alignment. And before tightening both of those down all the way, you can put the handle in place just to make sure that your 2 handle extensions are in the proper orientation as well. With the handle even loosely in place, you can go through and tighten both of the other screws. Next, you can grab this piece of laser cut and the pressure die. Now, you will notice that there's a second hole there on the side there, and you can find that corresponding hole here. This isn't required, but if you like, you can tap this hole to 3mm. I'm not sure that this will add any strength to the assembly, but if you'd like to do it, it's there for you to do that. Now, simply insert this piece of aluminum into the groove on the bottom side of that follower and line up both holes. If you did decide to tap that hole, this is when you'll want to add a piece of 3mm flathead hardware to that piece. Once you've assembled this, you will notice that one side is flat on the front, opposite that countersunk screw area. That side is going to face the handle of the bender. This is going to go in place, and you're going to line it up with this hole, and you're going to add another piece of M4 by 30 hardware. Once you've pushed it through, you can add another M4 lock nut. Again, we're just going to loosely put this one in place like the top. We can set this aside for a moment, and we can grab the base plates. For the base, you have a couple of options. This plate stacks on top of here. Now, these 3 holes down here were added in case you want to attach the side plates to this piece here. It's not really necessary. It's all just getting clamped in a vise. But if you do want to attach it, you should countersink these holes. That way it gives you a nice flat surface on the actual aluminum that you're clamping to instead of just 3 screw heads that would be sitting on there. But again, it's not required to do this. If you do want to countersink it, get yourself a countersinking bit. It'll make things much quicker. Make sure that when you countersink it, you don't do the same side on both of it. You need to do one on one side and one on the other. Now you can take and attach the aluminum plates to the center portion. These don't bolt all the way through. These thread into that section using some short countersink hardware. If you did decide to do this step, it does make this part easier as well. Using 4 pieces of M3 by 30, get the top and bottom portions assembled together. Now that you've got the base portion tightened down, we can go in and tighten the 2 M4 screws and lock nuts. You don't need these to be overly tight. You do want them just to engage the nylock portion of the nut and then allow everything to move freely. The handle should be able to move all the way back to this edge of the bender. Now it may touch or rub on that inner pressure die, but things will wear in. You just want it to not have too much slop in there to make sure everything stays in place. Next, we need to add the hardware to our grip, and for that you'll just need some M3 screws and the lock nuts on the back side. Now for the last portion of the assembly, we need to fabricate this loop here. For this, you're going to need the piece of strap and that bend jig, as well as a piece of short M3 hardware. So line up the hole in the strap with the hole on the bend jig and take that piece of hardware and push it through there. This is just going to be to kind of hold it in position. From there, we're going to just take and bend this around. It doesn't take that much force. You may not need any tools. Maybe you do, just depending on how, your grip strength or whatever it is, but hold it in place and just kind of bend it around that jig. Now, if the hole on the other side doesn't exactly line up, don't worry too much about that. Just pull that piece of hardware out. And you also don't have to worry about it being completely even on both sides. Having it a little bit open, not a problem at all. We're going to take the part now and we're going to line it up on this tab that sticks out from the bending die. Push a piece of hardware through, get everything lined up. You can use some pliers to get it to pop over the edge of that screw, and then just add another nylock to the other side. You do not want this to be tight. You want this hoop to be able to move. So don't get that tightened down, just get it held in place. This strap here is what holds the pressure as you're actually bending the tube around. So the benefit of having aluminum in this over 3D printed is pretty high. Now everything on this is done with pretty tight tolerances, so you may need to just get everything kind of worked into position. One easy option for this is to grab your 3/16 chainsaw file and just make sure that a piece of 3/16 tubing can fit through everything. Just work it in through there until everything moves freely. The file will go in smoothly, but it may drag pulling out just because this little strap wants to come outward. So just hold it back with your thumb as you're doing that. This should only take you 30 seconds or so. That'll just make sure that everything passes through there smoothly. It'll take off the little ridges of the 3D print, help make sure that this is not interfering at all with where the tubing will go either. Now, if you have a piece of 3/16 tubing, you can check that everything goes into place properly. That's all it takes to build the bender. Now, let's show you how to use it. Now to use it, as I was saying, this is made to fit into a vise. You'll set it down and it should sit nice and level with that when it's in your vise. Then just cinch your vise down snug and you're good. When you first get your bender, the one thing that I'm going to suggest that you do is take a piece of tubing and make a mark on it. Give yourself an inch or so from the one edge. Just make a random mark. So we're going to take that mark there. And what we're going to do is we're going to line up that mark with the edge of that loop that we bent. You do need to be somewhat exact with this. So what I'm going to do is I'm going to make sure that the loop is pushed all the way in or up against the die. And then I'm going to line that black line up so that the very edge of it is against it. Not the whole thing being covered, but just the very edge. So once I have that in place, we take the tension out of the bender just by putting a little upwards force on the handle, making sure that it's still in the right spot. Then we're just going to bend this to a random angle, say about 45 degrees. And what we can do from here now is take and measure from the edge of that line that we made until where we think that the radius starts on our bend. I'm going to take a straight edge, put the tube on there, and then right where it deviates, I'm adding another line. Now, what I'm going to do is I'm going to measure from the edge of one line to the edge of the other. With this, I get 11 millimeters. I'm going to do it one more time just to check. So I'm going to add another line over here. And just to call our shot, I'm going to take and put second line 11 millimeters away. Now I'm going to bend this again with this line starting at our strap. And what I can guess is that our next bend is going to start right where I put that second line. There was our next line. There was the line that I said our bend would start at. And if I use my straight edge again, I can see that my bend is starting to deviate right at that line. So double checking, that's great info. I'm going to show you why I did that. So let's say you have some sort of template, whether it be a 3D printed type of template here that I use when I'm building my buggies, or you just got a piece of scrap that you've kind of mocked up into place and want to replicate. Normally with a single bend tube like this, I just start a little bit long, mark it, go, and then I've got some wiggle room. But if you've got a situation where you have something with two bends and you've already done the first one and you need to nail the second one, that's where that 11 millimeters is key. In practice, I would never start this close, but just for the purpose of demonstration, I'm going to make a mark right where the radius starts, make a second mark 11 millimeters back, now I can check that it matches that bend perfectly, and you can see that I left exactly the same amount there that we started with. Now if I was going to go to the next one, I would just hold that in place, mark the start of our next radius, 11 millimeters back. This is actually a compound bend because this portion and this back portion are at two different angles, so I do need to pay attention to that. And now we can take the template and double check that everything matches up just perfectly. And that's basically the hardest part about any bender. So that's just my method, and it works the same way on this as I've been doing it for years. And that's all of the details on my new bender, except for this little angle meter, which I touched on briefly at the beginning. Is this angle meter needed? No. Is it fun? Sure. So what I have done is I've taken a digital angle finder or a digital T-bevel, whatever you want to call it, and I've disassembled it and then repurposed it onto this bender. Now, it does require that I've printed 2 sets of gears for this, as well as a mount for it to go on. It's fairly repeatable. I've been having good luck with it. Found that when I put a piece of tube in there, I just need to make sure I take out the slack and then zero it to make sure that I'm starting at the proper point. And from there, I can bend it, make sure that I'm not getting any spring back, and then read the degree. If that's something that may interest you, I am working on finalizing this design, and then that will be available separately on my website. It's all just some additional 3D printed parts. It doesn't require changing any of the aluminum parts or anything like that. Everything goes onto the same bender that you got previously, so you could add it at any point down the road. This, again, I am still working on the final version of it. I want to beef up a couple of areas and try and make it as solid and as repeatable as possible. I'll have it up on my website here soon, but likely in a beta. And while it's in beta, it'll likely just be a free download. So once I feel good enough for you guys to give it a shot, it'll be up there. Once it's finalized and finished, it might be $1 or $2. That's the fun part of building your own tools. You can build them better down the road. So I hope you guys enjoyed it. I hope if you're interested in fabrication that this is something that may fit your needs. If it is, let me know. Drop a comment below, hit the like button if you haven't already. I have channel memberships up if you'd like some more information on behind the scenes stuff, you'd like to see these videos early, or you just want to help support the channel a little bit more. But as always, I appreciate all of you guys who watched. Hit the like button on your way out. Subscribe if you're not already. Hit the notification bell so you see the videos as soon as they get uploaded. And thanks again. We'll see you on the next one.